Okay, so we're going to look at the short way to find the derivative. So we're going to pull up some of the problems you just did. Alright, such as number 7, the g of x equals 2x squared plus 7. And the derivative of this thing was 4x. So can anybody see what happened to get 4x? Kurt. There you go.
What?
So I take the exponent times the coefficient, so 2 times 2 gives me 4. And then I take the exponent minus 1, which gives me x to the first power. Okay? Now,
Are you squaring it or are you multiplying from 2?
multiplying.
Okay.
Now, what happened to the 7 when we took the limit of the difference quotient? It cancels out. Same thing on the derivative. If I've got a constant sitting there by itself, the derivative of it is going to be 0. It goes away. So the derivative of it is 0. So let's look at another one.
How did you go about? How did you get 4x?
I did 2 times 2 is 4.
Yep.
And I did 2 minus 1 is 1. So that's just x to the first, which is just x. Okay, this one is number 3. So I want to find the derivative of this one. Now, the derivative symbol is this little tick mark up here. It's called prime. G prime of x is how you read it. So G prime of x, same thing as the derivative. So G prime of x would be 4. So over here we're looking for f prime of x. Okay, so what happens to the 3 on that one?
Cancels.
It cancels, so the 3 goes away. What is my exponent on this first x? 1. So I do 1 times negative 2, which is negative 2. Then what do I do with the 1?
You subtract.
Subtract 1. So what's 1 minus 1? 0. What is x to the 0 power? 1. So we end up with just negative 2 when I take the derivative of this piece. Then I move over. 2 times negative 1 is negative 2. 2 minus 1 is 1, so I just get x. So my derivative is negative 2 minus 2x.
So what about when it's in a...
We'll get there. Okay, here's one from another one that you've done. This time let's do y. So y equals 5x squared. So 2 times 5 gives me 10, and my new exponent would just be 1, so we leave it as 10x. 2.
I swear it's not contagious.
I swear it is. It's like, yeah.
So 5x to the fourth. 20x to the third is what it would be. Alright, so that's all fine and dandy. So let's get to where they're a little bit more difficult. Okay, f of x equals 4 divided by x. What do you think on this one? Kurt?
If you have an exponent, you times it on the top, and then you
Say that again.
if you have an exponent at the bottom, you times it on the top, and then you make the top negative, and then you add 1 to the bottom.
Alright. Here's what I want to do. First thing I want to do is move this to the top. So that makes it x to the negative 1. And then I do what I've been doing. So I do negative 1 times 4 is negative 4, and then I subtract 1. Negative 1 minus 1 is negative 2. Then we want to take it back down to the bottom, and I get negative 4 over x squared. What Kurt said works as well, but I wanted to show you what you're doing technically to get that answer. So the easiest thing, the most consistent thing is to move it up, take the derivative, move it back down. have y equals 6 over x squared. Negative 12 over x and third is what it's going to end up being. Let's go ahead and move it. So I get that. Then I take the derivative. Negative 2 times 6 is negative 12. I subtract 1, makes it negative 3. I move it back down. I end up with negative 12 over x cubed.
So is this where you were saying the other day how your exponent is going to be +1?
Why the bottom exponent is going to be one more than it started? Yes. All right. So I have y equals 3 over 2 times x plus 1 cubed. Still move it up. Remember, what's the only thing I want to move? The x plus 1 is the only thing I want to move. So I'm going to leave it as 3 over 2, then I'm going to make it x plus 1 to the negative 3. That's the best way to think about it. Alright, so we take the derivative. I multiply by the negative 3, that makes it negative 9 over 2. X plus 1 to the negative 4. And then I move it back down. Negative 9 over 2, x plus 1 to the 4.
How'd you get negative?
Question?
How'd you get negative 9?
I did negative 3 times that. So negative 3 times 3 is negative 9.
Okay.
Alright, so now let's move on to the square roots. So f of x equals 5 square root of x. I want to take the derivative of this. Any thoughts on this? Say again? 1/2. Very good. So change it to exponential form. So 5x to the 1/2 power. And then everything's the same. So 1/2 times 5 is 5 over 2. I subtract 1 and I get negative 1/2. So that means I need to end up with 5 over 2 x to the 1/2. Now what can I put instead of x to the 1/2 if I wanted to?
Square root.
Square root of x. You don't have to, but you can.
Where'd you leave the 2?
Yeah.
How'd you get it? How'd you find
When you
Because
multiply
I had to do 1/2 times 5.
It would be 2 square root of x. Square root of x, right?
Correct. The 1/2 only goes to the x. Alright, y equals 2 over 3 square root of x.
Okay, 1/2. Take the top one, not there.
Really?
That big.
So rewrite it. So I have 2/3 x to the negative 1/2. So I rewrite it first. Now I'm ready to take the derivative. So negative 1/2 times 2/3. Negative 1/3, right? So the 2's are going to cancel. 2's are going to cancel. And that makes it x to the negative 1/2 minus 1.
1/2.
Negative.
Oh, minus 1.
3 halves.
3 halves. You guys are boring, Nick. You're boring. It says pick it up.
That's fine.
All right, then I want to move that back down. So negative 1 over 3x to the 3 halves is what we end up with. Now, when we did this on our paper, it would have, or with the limit of the difference quotient, we would have ended up with that. Is x times the square root of x the same thing as x to the 3/2?
Yes.
Yes. Because this is the same thing as x times x to the 1/2, and what do you do when you multiply variables together? Add the exponent. So 1/2 plus 1 gives me the 3/2. So x times the square root of x is the same thing as x to the 3/2. All right, and we're going to add one more thing to what we've been doing. All right, so we're going to find the derivative, we're going to find the slope of the tangent line, and then we're going to write the equation of the tangent line. Okay, find the derivative, slope of the tangent line, and then we're going to write the equation of the tangent line. All right, so what do I want to do to find the derivative?
0.5.
X plus 3 to the 1/2 is what we want to look at. So then when I take the derivative, that gives me 1/2 x plus 3 to what?
Don't you get 1/2? Oh, did you just move it?
I had 1/2. There's a 1 there, so 1/2 times 1 gives me 1/2.
Oh, okay.
So that ends up being negative 1/2 because 1/2 minus 1 is negative 1/2. So move that to the bottom. I get 1 over 2 x plus 3 to the 1/2. There's my derivative. All right, so now I'm ready for my slope. So what do I do to get my slope?
So just plug 6
I plug 6 in. So I plug 6 in. So 1 over 2, 6 plus 3 to the 1/2. So 6 plus 3 is 9.
The square root of 9 is 30.
Square root of 9 is 3. 3 times 2 gives me 6. So I have a slope of 1/6. Now I want to write the equation of a tangent line. What two things do we need to write the equation of a line? Slope, and you guys are trained to do y-intercept. I need to quit doing that. Slope and a point is what you want. Now, y-intercept is a point. The y value is 0. Is that right? No, the x value is 0. Okay, so it is a point. They need to quit training you to do that. I wish we could quit that. It's no good. Slope and a point. Okay? It's not your fault. You've just been trained that way. You've been trained incorrectly. Just like you've been trained that you can't have radicals in the denominator. Okay? You've been trained that. You should not be trained to do that. There's nothing wrong with it. It's a good skill to have to move the radical up, but you don't have to do it every time.
False.
Same thing as writing the equation of a line. Yes, you can write the equation of a line if you have a y-intercept, but that's not what you don't have to do it that way. Alright, so if I have a slope and a point, what form am I going to put it in?
Oh, that.
If I have a slope and a point, I'm going to put it in point slope form.
That's what I meant to say.
What is point slope form of any line? That's slope intercept. See, you guys have been brainwashed.
Is it y
There's something
It's something along those lines.
I said it. Okay, I didn't
Oh,
I did say y.
I had all those.
That is point slope form.
Never learned this.
That is point slope form. That is all you need to write the equation of a line. So all I have to do is plug into those 3 spots. So I need y minus my y value. What is the y value in this problem? 3. We just figured out that my slope was 1/6. And then I need x minus my x value, which is 6. That is a perfectly acceptable equation of a line. I know you have been brainwashed to do what from here? Solve it for y. You do not have to do that.
I'm already halfway through it in my head.
You do not have to do that. There is nothing wrong with that. And those of you going to calculus with me, we're going to write it that way and we're going to stop. We're never going to go. Just leave it like that. Stop.
Add 30. That's all you need to do.
So, there is the equation of a tangent line. Now, we're going to graphically verify that is the equation of a tangent line. How do I do that? How do I graphically do it? I'm going to graph my function.
So,
I'm going to graph my tangent line. What should happen?
if they should like a little bit.
They should increase.
They should touch where?
On the
At
point,
6-3.
At 6-3. So let's graph it.
Hey, but it should be.
So my graph is a square root. Was it x plus 3?
Yes.
Plus 3.
How are you gonna write it if you didn't select the one?
You do have to get y by itself, but what I'm saying is it is not necessary unless you're wanting to put it into your calculator. But I do not have to solve it all the way. So it was control divide. What was the slope?
1/6.
1/6.
Isn't that wire or something?
It was x minus what?
6.
Plus 3.
And if I move the 3 over, plus 3. So there it is. Okay, and what was the point we were looking for? 6-3. So 1, 2, 3, 4, 5, 6, and if I go up, that's my point. There is my tangent line. So that shows you we're doing it correctly. So that's what you're going to do today on today's 6 problems. You're going to find the derivative. First thing you're going to do is find the derivative. Then you're going to give me the slope, and then you're going to give me the equation of the tangent line. That's what I want on today's 6 problems. So, to find the derivative, 2-step process. What is it?
The limit of the.
Multiply by the exponent and
And subtract.
subtract 1 from the exponent. If you've got something in the bottom, or you've got a radical, you've got to change it before you do it. All right.
I'm going to finish.
That works.
Almost out. You're just mad.
Okay.
Okay, I want the derivative, I want the slope, and I want the tangent line on all 3 of those. Now, there are 2 points listed for each one. Just give it to me for the first point. You do not need to give it to me for both.
Is this the tangent line, the y line?
Is that the formula?
Yes.